What's up, everyone? Welcome back. Patrick here, and moving on to another question. This one's going to be fairly tricky, fairly unique. So we're given a triangle A, B, and C, where point X, 3 and negative 2 is the midpoint of AB, point Y, 2 and 6 is the midpoint of BC, and point Z, negative 3 and 2 is the midpoint of AC. We have to find the coordinates of the vertices of the triangle A, B, and C. Now, before getting into the actual math of this, I want to just quickly go over, you know what, let me make a bigger triangle, go over some properties here about how the vertices of a triangle, so let's call this vertex A, vertex B, and then vertex C, relate to the midpoints of the sides. So notice in this case we have X, which is the midpoint of AB, so I'll label this point here as X. And then we have point Y, which is the midpoint of BC, which would be like over here. And then point Z is the midpoint of AC, which would be like over here. All right, let's not worry about the coordinates for now. I'm just going to talk about some general properties for any triangle. So this kind of looks like an equilateral triangle, but it really doesn't matter what kind of triangle you draw, whether it's an isosceles, scalene. The properties I'm going to discuss here are going to hold for any triangle. So notice that if we join the midpoints right here, we actually get another triangle. Let me make this line a little bit more straight. And so here's what happens. This line, for example, XZ of the smaller triangle is actually going to be parallel to this line over here for the larger triangle, the line B and C. And then notice that this line, BY, is half of BC because this is the midpoint, right? So this line, and this line, they're all parallel. Okay, so I'm going to represent the slopes of these lines with this one dash mark over here. And then the same thing for the rest. So this line over here, the slope of it, let's represent it with 2 dashes, is going to be parallel to this line, and it's going to be parallel to this line as well. And then same thing, this line over here. Let's represent the slope of it with 3 dashes. This line is going to be parallel to this line and this line. Okay, that's always going to hold no matter what shape of a triangle you draw. You can draw any kind of shape and you're going to see that this line parallel to these lines, this line to this to that. Okay, so that's the first property I want to go over, is how the lines are parallel. Now, another property, not only are the slopes equal here, but this length over here, let's call it length N. This length here is actually half of this length, BC. And because it's half of BC, and then over here at this point Y, we actually split it into 2 halves, that means that this length and this length and this length are equal. So this length, and that length of all those lines, XZ, BY, YC, they're all equal. The common property you'll see is that this length is half of BC. Okay, if you're not, if they didn't draw like this midpoint over here, so if you had a triangle, a lot of times you'll see like this and this. The property would be this is M and then this is 2M, but in this case we actually split up the 2M into an M and an M, like that. Okay, and then the same thing for all the other sides. So let's say this is length N, then this whole side's going to be length 2N, which means this is going to be N, this side AZ, and then this is going to be N as well. And then if this length is O, then this is going to be O, and that's going to be O as well. Okay, so that's the general properties that we're going to be using to solve this particular question. So what I'm going to do is draw another triangle now, kind of get rid of all that stuff we drew. And let's now work with what we're given. So we got coordinate A, vertex B, and then vertex C, and then the midpoint is X of AB, the midpoint Y of BC, and the midpoint Z of AC. And now let's actually work with the coordinates. So we have point X, which has coordinates 3 and -2. Y has coordinates of 2 and 6. And then Z has coordinates of -3 and 2. Another thing I want to mention with a question like this is I highly recommend just drawing a triangle like this, even if it's not corresponding to the proper Cartesian coordinates. Because if we actually graph these coordinates initially, so like 3 and -2 would be like down here, and then -3 and 2 would be like up here, and then we have 2 and 6, which would be like up here. If we draw the points like that, initially, it's kind of hard to see where A, B, and C is going to be on this triangle. You have to kind of guess it out. And you can guess it's going to be here, and then maybe like here and here. But it just takes a lot more work. So initially what I recommend is just drawing a triangle like this. Don't worry about the coordinates where they're supposed to be on the Cartesian plane. Just label the coordinates like that. And then work with just this triangle. And then after, you could take these coordinates and put in a Cartesian plane. Okay, it's just going to make the process a lot smoother, in my opinion. That's what I personally do. Okay, I don't take these and I graph them on the Cartesian plane because, again, then it's hard to tell where those vertices are going to be. Just put the points here. Like I know, for example, an x value of 3 is to the right of an x value of -3, right? So if we look at it from a Cartesian plane perspective, this doesn't really make sense. But we're just using this to get the coordinates here, and then we could put in a Cartesian plane after. Okay, so here's what we do. We know that, for example, this side, okay, and this side have the same slope, and they have the same length. So what we can do is we can figure out how do we go from 2, from this x value of 2 to -3. How do we go from here to here? Well, to go from 2 to -3, we have to subtract 5. And then what you can do is you can use the exact same proportions from this point to this point, because the slope is the same and the length is the same. Okay, so if from 2 to -3, if we're subtracting 5, then from 3 we have to subtract 5 as well. What would we get? We would get -2. So this here, the x value of A would end up being -2. And then you do the same thing for the y values. So going from 6, okay, from 6 to 2, what did we do? We subtracted 4. So what we would do is with this y value, we start at -2, we would subtract 4, and get -6. And that's how you can find the vertex of A, right? And we could have also, instead of maybe using from here to here, we could have also went from here we could have used this proportion to this, because we know this line and this line are parallel and they have the same length. So notice that from 2 to 3, what do? We added 1. Well, notice from -3, if we add 1, we get -2. If we go from 6 to -2, we have to subtract 8. Well, notice from 2 to -6, we also have to subtract 8. So even if you went this way, if you use this line and then went from this coordinate to find this coordinate, you'd get the same exact value, right? So it's pretty cool how it works out. And so now you could use this for finding point B. So for point B, we can use this point to get to here, or we can use this point to get to here. I'm going to use this point. Now, this line over here is, let me erase this, is what? It's parallel to this line and it has the same length. Okay, so if this coordinate is at 3 and -2, right, that's coordinate x. Notice that from here to here, it's the same as from here to here. Okay, so how do we go, starting with the x values? Notice we go from -3 to +3. Okay, how do we get from -3 to +3? Well, we added 6. So same thing here, to go from 2 to this x value, we start at 2, we're going to have to add 6. Okay, it's proportional, going from here to here, here to here. So if we add 6 to 2, we get 8. So we know the x value of this coordinate is going to be 8. And then what about the y values? Well, we go from 2 to -2. What do? We subtracted 4. So starting at this y value of 6, if we subtract 4, we end up with a y value of 2. So the coordinate of B would be 8 and 2. And then finally with C, let's, you can go from here to here and go from here to here, right? You could use this and this. I'm going to use, again, it doesn't matter, you should get the same coordinate, but I'm going to go from -3 to 2, -3 and 2 to C, and I'm going to use this to that, right? This and this are parallel and they're the same length. So how do we go from 3 to 2? We subtract 1. So what's -3? Subtracting 1, it would give us -4. And then how do we go from -2 to 6? We add 8, right? -2 to 6, we add 8 for the y values. So if we start at 2, we also have to add 8, which would give us 10. And that's it. Those are the coordinates. And then when you get to this point, you can actually check your answer. Notice you could take the vertices and then find the midpoint. So notice that if we take the midpoint of AC, we add the x values, -2 plus -4 would give us -6. Dividing it by 2 would give us -3. And then if we take -6 and add 10, that would give us 4. Dividing it by 2 would give us 2. What about between 8 and 2 and -4 and 10? Well, 8 plus -4 would give us 4. Divided by 2 would give us 2. 2 plus 10 would give us 12. Dividing it by 2 would give us 6. Okay, 8 plus -2 would give us 6. Dividing it by 2 would give us 3. Then -6 plus 2 would give us -4. Dividing that by 2 would give us -2. So we could be pretty confident that those vertices that we got are correct. Okay, so that's personally how I do a question like this. And then once I have this, then go ahead and graph it. right? If maybe your teacher requires it, maybe they'll just want A, B, and C, and then you could just finish off the question here. You could just say these were the vertices. But if they want you to show it on a graph and it has to be all proportional, well, now you could graph everything. So what does it go up to? It goes up to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The negatives go up to -6. So 1, 2, 3, 4, 5, 6. Then we'll have 1, 2, 3, 4, 5, 6, 7, 8. And then we'll have 1, 2, 3, 4, 5, 6. Okay, so now proportionally graphing this, -2 and -6 would be like down here. So this would be vertex A. Okay, and then vertex C would be -4 and 10, which would be like up here. And then vertex B, 8 and 2 would be like over here, like that. And now we could join these, so we'd have, this is going to be more exact if you use graph paper, but just kind of want to show you kind of generally what you're going to get. And then the midpoint, so like x between A and B, 3 and -2, 3 and -2, so that's like over here. Again, this is not like to scale. On graph paper, you would get the exact coordinate. You know what? I'm not even going to put the coordinate. I'll just put x over here. And then y is the midpoint of BC, which is at 2 and 6. So that's going to be like 1, 2. Anyway, you get what I'm saying. So this is going to be y. And then z, -3 and 2. That's going to be like over here. Like that. Right? And then if you started, again, if you started with these coordinates, graphing them first on a Cartesian plane, it would be tough to see where these vertices are initially, right? It would take you a lot more time to do a rough sketch. So before putting it on a Cartesian plane, a question like this, I recommend just drawing it out like this, even though it doesn't make sense from a Cartesian perspective, right? Like 8, an x value of 8 isn't to the left of an x value of -4. But again, just draw the triangle in an abstract way, get all the coordinates, and then after you can plot everything and sort of check your answer and see if everything makes sense on a graph.